I'm going to make a quick video here that shows you how to write a calculator program that does a few simple math operations. So there'll be a decision for the user to make, and then I'm going to put it all inside of a loop so that the program will run continuously, and when you get to the end of whatever calculation you're doing, it'll ask if you want to go back to the top and do another calculation. So basically, I'm writing the program that you guys have been working on in class for about 3 days or so, and if you're not done with it, then this will obviously be helpful for you, particularly when it comes to figuring out how to put the entire program inside of a loop to get it to continuously run. If you are done with it, then it's still worth watching, because I'm going to focus a little bit on good syntax and indenting, so that getting the right code structure and such. And even if your program is running and working, you might be able to improve it by watching this. Okay, so let's go. Here I am in my intro directory on the computer science server, and I'll make a new file. I'll just call it, how about math.rb? And apparently I already have a file called math.rb, so let me get out of here, quit this, and instead I'll call it how about calc.rb? There we go, that one's blank. Okay. So I think that the big picture here is I want a calculator that does two different functions, and I want to give the user a choice, which do you want to do? And then again, as I said, I want the calculator to run over and over again and give the user a chance to either quit the program or go back to the top. I think, just to keep it simple, the two different calculations I'll do will be addition and subtraction. It doesn't get any easier than that. And I'm going to start simple, because many of you asked me how to begin when you started writing this code, and my answer is always begin with something that you know you can do. Start simple. You don't have to build the whole program at once. So I'll start off modeling that, and I'm going to begin just by making a simple addition calculator, and then we'll build it bigger from there. This is how you should work, starting small and then going big. So here we go. We'll start off with a prompt to the user. Let's say, please enter two numbers for me to add, like that. And then we'll get the numbers. So let's call them number one, like that. Very often in computer programming, people will use variables like num1 equals, or no_1 for number one, or something like that. We can do either one. I'll use this convention. I'll say number one equals gets dot to_float. So we'll turn, I'm sorry, it's just 2f. So we'll turn the number to a float as soon, we'll turn the input to a float as soon as we get it. Number two equals gets dot to float as well. And then we'll calculate the sum, and we'll call it sum. We'll say sum equals num1 plus num2. And then we'll reply or report back the result. So put s. The sum is, leave space, and then we'll put the variable sum, and got to remember to turn that to a string since we're concatenating it with the phrase right back here, the sum is. Okay, that should do it. Let's write it, WQ, Q for quit, and let's try running it. Run calc.rb. And there seems to be a problem with it. Let's see. Front is not a typo. I'm sorry. What am I thinking? It's Ruby. Calc.rb. There we go. Please enter two numbers for me to add. 3 and 5. There you go. The sum is 8.0. Okay, so that works. Let's clear the screen. Go back there. Edit the file. Okay, there it is. So now I've decided I've got one thing working. Let me try to put this inside of a conditional statement. A conditional statement is a fancy word for an if, else if type of situation, because I want to ask the user, hey, do you want to add two numbers or do you want to subtract two numbers? So let's go and do that now. All right, so back in insert mode. The first thing I'm going to do is indent everything. And the reason I'm doing this is because I know that I'm going to take all of this code and wrap it inside, as I said, an if, else, end type of structure. So by indenting it all like that, I keep the code a little bit cleaner, a little bit better looking. I'm going to throw some lines in here as well, just to make some space. Okay, so let's go up top here, and let's start off with a greeting. Welcome to my calculator. Enter A. You can use single quotes like that inside of double quotes. To add two numbers, or, and let's say enter, and now it's going to wrap B to subtract. Actually, that's silly. Let's make it S for subtract numbers. Okay, just like that. Sorry for the text wrapping to the next line like that. It's just that I'm zoomed in so big so you can see the text in this video that I can't type too much on any line before it wraps like that. All right. And I think what we'll do at this point is get input from the user. So let's just say response equals gets.chomp, just like that. And then, of course, we have to look at the response and make a decision. And this should not be indented. This should actually be back there like that. Okay. And then, of course, as I said, based on that response, we'll decide whether we're going to add the numbers or subtract the numbers from each other. So let's do that now. So let's set up the conditional statement. So if response is equal to, and what did I say? They could enter A, like that. Then we want to do all of this addition that we have here down below. So that's all set. I don't need to do anything else. I'll just come down here and then I'll write else if response equals subtract, like that. And then we have to write the code for what happens if we want to do subtraction. Okay. So I can do all this all over again. I can write puts, please enter two numbers for me to subtract. And then like that. And then down here I can say num1 equals gets.toFloat. But I feel like I'm repeating myself if I do that, because I've already written that code up here. Of course, that's in a different situation. What I could do is I could ask the user to input these numbers right here, number 1 and number 2, before I actually go into this conditional. And then I would have them, and I wouldn't need to copy the code twice. Now this obviously works in this case because my first operation is addition, my second operation is subtraction. Both of them require two numbers. But if you were doing something more complicated where your if was, say, adding numbers and your else was, I don't know, calculating the volume of a sphere or something like that, then you'd have very different inputs for the two different situations, so you wouldn't be able to do what I'm about to do. But again, in the interest of keeping the code clean, let's do this. So we'll come over here and just get rid of these two lines like this instead of having them there. I'm going to go up here and I'm going to put them right here. And at this point, I'll ask the user for the two numbers. So please enter two numbers. And presuming the user already knows whether or not he or she's going to add or subtract these numbers, because that person has already chosen that. They've entered either an S or a up top here. So now we'll get the numbers. So num1 equals gets dot to float, and num2 equals gets dot to float, just like that. And now we'll set up the conditional. Obviously, we don't need this line here anymore, so we'll get rid of it. All right, so the variables number 1 and number 2 are already available up here. So now I can use them down here inside this conditional. And then here, moving down inside the subtraction case, again, I can get rid of this line. All right, by the way, in VI, a quick way to get rid of a line is to hit escape, so you're in command mode, and then just hit DD really quickly, 2 D keys, and they need to be together quickly. And so I don't need that either. So now all I have to do is simply say difference, because that's what we call it, equals number 1 minus number 2. And now I know that we're getting into a situation where, gee, do we want to subtract number 1 from number 2 or number 2 from number 1? And in this case, because I want to keep this simple, I don't really care about that. We could design it to be more specific and tell the person to put the numbers in a certain order or something like that. But for the sake of what I want to accomplish with this quick video, it doesn't really matter. Okay, so we're just going to assume we're going to subtract number 2 from number 1 like that, and then we'll output the result. And so the difference is like that. And the same thing as before, plus the variable difference, dot to string, just like that. And then we will end the if-else-if structure. I suppose before we do that, maybe we should write else puts you did not give me a valid response, in case they enter something other than S or A, like that. And then the end. Every if else structure has to have an end. Even if you only have an if, you still have to have an end with it. So again, just one more time, let me stress, the idea when writing code is to write as few lines as possible to accomplish what you want to accomplish. So don't repeat yourself if you don't have to. And in this case, since both addition and subtraction use 2 numbers, I might as well get the numbers up here instead of getting them both in here and again in here, simply because that's more code. And more code means if you have a problem, there's more things to look at to fix that problem. More code means it's harder for somebody else who's looking at your code to find out where the problem is as well. And there are exceptions to this. There are times when streamlining things can ultimately make it more complicated to understand. So there's a limit in some cases for doing this. But again, I wanted to show you kind of how computer programmers think. And we think in terms of being as efficient and clean as possible. And so that's why I did that. Now, again, I'll reiterate the fact that for some of you this would never work, because the calculation you're doing here and the calculation you're doing here are totally different than each other. One of them requires 1 number, the other requires 5 numbers, something like that. And so you can't get away with this trick, but in this case I can, so I'm going to do it. All right, let's run it, and hopefully it works. Ruby, calc.rb. All right, and there's the prompt. So I'll start off by adding. So A. Okay, please enter the 2 numbers, 3, 4, and the sum is 7, and the program's over. Well, let's try it again. This time I'll hit S for subtraction. Please enter 2 numbers, 2, 5, and the difference is -3, as you would expect. All right, let's clear the screen. This time I'll just enter something meaningless. I could still put the numbers in, unfortunately. Might want to think about how to fix that, but it's okay for now. Okay, and the program quits. All right, super good. The last part of this is, how do I get it to loop? so it runs over and over again. Let's go back in and edit it. Okay. I'm going to shrink the font a little bit, I think. It's just a little bit big. In order to do that, actually I have to quit. Okay. Maybe that'll work. Okay, maybe a little better. Okay, I'm going to wrap the entire thing inside of a while loop to get it to happen over and over again. So that means that everything needs to indent. So I'll start here, and I'll tab that one. I'm not going to tab the next line because it's just a text wrap, which is unfortunate. It just has to do with the size of my window. So we'll indent that. This. Now, admittedly, this is incredibly annoying. And when you start working with text editors other than VI, when you start using something a little more sophisticated, you'll find that there are actually key commands and menu commands to just take a whole section of code and push it over and indent it, even if it's thousands of lines, all at once. And I don't know, maybe there's a way to do that in VI too, but I just don't happen to know it. But anyway, there you go. So I did that in advance because I know now that I'm going to set up a loop, put this whole thing inside of it. And so this exists within that loop, and I'm trying to keep the code structured to look kind of like, I like to describe it as an outline. When you learn to, whenever that was, back in middle school, when you learned to write outlines, Roman numeral 1, and then you listed like capital A under that, and it was always indented, and then the number, little number 1 indented from that. And that's how we code. That's how we do it. And it just makes it easier to follow what's happening. The Ruby interpreter or compiler, or whatever you want to call it, doesn't care about your indentation. So indentation is for you and me and everybody else who looks at the code. And when your programs get big and complicated, it's absolutely essential or you'll never be able to figure out what's going on. So, all right, so now here we go. I'll go back to the beginning, and I'll start this idea of putting this all inside of a loop. So while, and in order to do this, I have to have a condition to check. So I'm going to make up a variable, and it's going to be called calculator underscore running. It's the name of my variable. And I'll say, well, calculator running equals true. And true is an example of something called a Boolean variable. Calculator running, in this case, is an example of something called a Boolean variable. True is the value of that. A Boolean variable is a variable that can have one of two states, true and false. That's it. And in this case, I'm going to make it true. So while calculator running equals true, do the following. Do everything that's nested under here inside the while loop. That happens before this end that I just typed. So you could see now everything in here will happen over and over again if this variable, if the value of this variable is equal to true. So what a while loop really is it's just a repeated if. It's like this one, it's like the if that's here, but it happens over and over again. All of this code runs sequentially, line after line after line after line after line, and then when it gets here at the end, the program jumps back up to the top and checks the condition again. And if that condition is still true, it runs everything again, and then it gets here and it jumps back to the top. And if that condition is still true, it runs everything again. And that's why it's called a loop. It happens over and over and over again. And if you don't give yourself a way out of the loop, then it'll just happen forever. The program will just freeze up and continue going, and you'll have to somehow force quit it manually, or you'll never be able to stop the loop from running. All right, so this obviously isn't going to work yet because I haven't even created this variable. So before I do that, before we run it, I have to come up here. I have to make that variable. So I'll make a calculator running, and of course I'm going to set it equal to true, because if I don't set it equal to true, then it's not going to be true, and then none of this will run. Notice I used a single equal here to actually assign the value of true to the variable, but here I'm using the double equal to compare the value of the variable to the value true. And of course it's going to find it true, and it's going to run again and again and again. But I got to give myself a way out. If I don't give myself a way out, then we can't ever quit the loop. So here's what I'm going to do. After this if-else-if situation here, I'm going to prompt the user to find out if he or she wants to continue. So puts, do you want to run this again? And then I'll just say y, n, and we'll assume that that's yes or no. You could obviously make that be a little more descriptive. Okay. So then I'll say answer, or probably better to do this, run again equals gets dot jump, like that. And then I'll say, let's go down a little, and then I'll set up a situation that goes like this. If run again equals n. Okay, notice it indents automatically. Then I'm going to take that variable called calculator running, and I'm going to set it equal to false, which is the opposite of true. And that way, when the loop ends, it goes all the way back up to the top. This condition here, while calculator running equals true, will evaluate to false, because calculator running is not equal to true. It's false. And then none of these lines will ever happen again. In other words, the loop will terminate. It'll stop running. Coming back down to the bottom. After the while loop is over, that's right here, after this end, I probably want to say something like, thanks for using this calculator. A final greeting like that as the program quits. And that's it. So we'll run it in a minute, but again, what I wanted to stress is the structure of this code. The fact that the biggest thing here that wraps everything else is this while loop. Everything is inside of it, and it's indented accordingly. And then comes the if, else, and conditional statement, and then the things that happen within each of those are further indented. Right? And then we come back out over here, right here, we come back out to the level that we were at before. And you can see we have another indentation here, and then we're back out here at the level of the initial while loop, which is slammed all the way over on the left side of the screen. Okay? That kind of code structure, if you can get in the habit of writing it like that, is absolutely key. And then the other thing is, notice how I did this. I started off by just getting a couple numbers to be added together. It worked. Then I said, all right, let's make a situation where I can either add or subtract. And I used the if, else, if type of structure, and it worked. Then I said, okay, now I want the whole thing wrapped inside of a loop so that I can actually have it happen over and over and over again. And it, well, we'll see in a minute, but it should work. And as I went, I built from something simple to something bigger and more complex, and eventually I got to where I wanted to get to. If you start just saying to yourself, all right, I'm going to start by writing a loop, and inside of that loop, I'm going to put a conditional, and then I'm going to make some choices. In other words, if you work backwards, it often doesn't go well. I mean, obviously there comes a point where you get good at programming and you can do that. And for something simple, like this, if you, for a programmer, obviously if you asked me to write this, I probably would do it that way. I would just start with a loop, and then I would, I would go for that from there, because this is a relatively simple program. But even when as things get more complicated for anybody, when you can't see how to do the whole thing as you sit down and start it, then you just work on a little piece of it, and then you make that bigger, and then you make that bigger, and eventually you end up with the full product. You sort of just build outward. So everybody does that when the job is complicated for them. All right, let's try this. By the way, one final thing. This could be written better down here. I mean, maybe I could have said yes or no. It's not really clear, what's going to happen if somebody types something other than n. I mean, actually, what's going to happen is this variable will stay true, and it won't quit. So the loop will just keep on running. So really the only way out of the program is to type an n. If you type anything else, it just keeps on going, because this variable here won't be changed to false unless you type N. And I don't know if that's necessarily the behavior that you want, but it's quick, it's simple. So let's see what happens. All right, here we go. Okay, let's start off with addition. So A, 2 and 6 is 8. Do you want to run again? I'll type in yes, but I could type in anything. It says welcome again. Let's subtract. 5 and 2, the difference is 3. Do you want to run again? Sure. I'll put in W this time. And again, it runs it again. Okay, let's add this time. Or actually, let's type in something meaningless. It still asks me for numbers, and that kind of bothers me. But at least it says you didn't give me a valid response. And then again, it asks me, do you want to run again? Great. This time I'll type no. It quits. Thanks for using this calculator. Okay? All right. Hopefully this will help you finishing what you're working on. And again, for those of you who are finished, maybe you picked up a little something about indentation or names of variables or something like that. All right. Thanks for watching. Bye.